We are discussing JEST Physics 2020 optics problems. Here we are having 1 marks MCQ problem. Let us read the statement of this problem. A particle of mass m moves in a one-dimension potential Vx equals to F0 mod of x, where F0 is a positive constant. Given the initial condition, that is x0 is equals to x0 for greater than 0 and x dash 0 is 0. Which one of the following statement is correct? The particle undergoes simple harmonic motion about the origin with frequency omega equals to 2 pi root over f0 by mx0. The angular frequency of the oscillation of the particle is omega equals to 1 by 2 pi root over f0 by 2 mx0. The particle begins with rest and is oscillated along the positive x-axis such that xt is equals to x0 plus f0 t square by 2m, and the angular frequency of the oscillation is of the particle is independent of its mass. Solution. We have from the problem Vx is equals to F0 mod of x, which can be written as F0 x minus F0 x for x less than 0 and x greater than 0. The force acting on the particle is defined as minus del by del x into x cap, which would be equals to vector f is nothing but equals to minus f0 for x greater than 0 and f0 for x less than 0. The condition of SHM is given by f is directly proportional to negative of position or x. So, but from here we can check it, f is independent of the position, so it is not proportional to the distance x. That means the motion of the particle is oscillatory but not in SHM. So let us now we should determine the time period of this oscillation. Let A, B, this point is x0, this point is minus x0, and this is origin x is equals to 0. Now at point B, Ke is equals to 0 and U is equals to U max. Potential energy would be maximum, and at this point also Ke kinetic energy would be 0, U is equals to U max. Now from this direction A, F0 would be towards the origin O, and from here F0 would be from here. So we have to determine the time period for this entire cycle. Now what is this entire cycle? If we consider the particle from that initially the particle is at position A, then it would go to B via passing through O and then again return to A via passing through A. Means if I'll take this time period would be T1 from A to O, then the total time period for this entire cycle will be 4 times of T1. So the time period for the entire cycle would be equal to T cycle would be equal to 4 times of T1. The time taken by the particle from A to O is T1 and is equals to twice x naught by A, and which is equals to 2x0 m by f naught. Here we have used the relation S is equals to ut plus half at square. Now, so the time period of entire cycle is T is equals to 4T1, that is 4 root over 2 x naught m by f naught. Frequency, the angular frequency for this entire cycle is given by omega is equals to 1 by t, that means is equals to 2 pi by t, by 4 root over f naught by 2 x naught m, which is equals to pi by 2 root over f naught by 2 x naught m. So let us check it out which option is correct. That means our option B is correct for this problem. We are discussing MCQ 1 mark problem of optics from JEST 2022 problem. Two fork A and B are struck instantaneously to obtain Lesage's figure. The figure go through complete cycle in 20 seconds. Fork A is located with wax so that it is not located, it is loaded. Loaded with wax so that cycle period changes to 10 seconds. If the frequency of fork B is 256.10 Hz, what is the frequency of fork A after loading? Now in this problem, write it down solution, there are two cases. Case first, when the fork A is without loading of wax. Let NA and NB are the frequency of fork A in absence of wax, and NB is the frequency of fork B. Now, according to the condition, of fork, tuning fork, we have NA minus NB is equals to 1 by T, implies NA minus 256.10 is equals to 1 by 20 equals to 0.05. That means NA can take frequencies 2.5, 6.05 Hz or 256.15 Hz. Since one can check it out, the fork after 4K is loaded with wax, the cycle period changed to 10 seconds. Since cycle period is decreasing on loading wax, so NA must be less than NB, which implies NA can take value 256.05 Hz in the absence of wax. Now we are gonna discuss case second, when the fork A is loaded with wax, its frequency NA is decreased to NA wax. Then, according to condition of tuning fork, N2 minus NB minus NA wax is equals to 1 by T2, that is 1 by 10, which means 0.1 Hz, or NA wax is equals to NB minus 0.1 Hz, which means 256.10 minus 0.1 equals to 256 Hz. So the frequency of 4K after loading wax is 256 Hz. Let us check out our option. So which option is correct? That means option A is correct for this problem. This is a 3 marks problem from JEST 2020 Optics. 3 polarizers are stacked normal to its central axis, along which is incident a beam of unpolarized light of intensity I0. The first and third polarizer are perpendicular to each other, and middle polarizer is rotated at an angular frequency omega about the central axis. The time-dependent intensity of the light emerging from third polarizer will be given by. Solution. Now, here I'll make a figure of 3 polarizer. Now for the polarizer 1, P1, path axis is this one. For polarizer P2, now the path axis is rotated at an angle theta degree with respect to this, and for the P3 path axis is this. So that is P1, that is P1, that is P2, and that is P3. These are the path axis with respect to this polarizer. Now, originally this is a beam of unpolarized light. So once this is passed out, it is having frequency I0. This will allow light like this, and in this region frequency I1 would be I0 by 2. Now when this polarizer P2 is rotated at an angle theta, and where theta is represented like omega t, we'll check it out here. The component of light which is passing through P2 would be I2 would be I1 cos square theta. Okay. And for this P3, I3 would be I2 cos square 90 minus theta. So once it would be rotating, path axis would be only vertical component which would be passing through it. So in this case you would be having this much. So intensity after emerging out from the polarizer P3 would be I2 sin square theta, and whereas I2 was I1 cos square theta into sin square theta, and whereas I1 was I0 by 2 cos square theta into sin square theta. Now I can write it down this as I0 by 8 into 4 cos square theta sin square theta, that is I0 by 8 sin square 2 theta, which can be written as I0 by 8 1 minus cos 4 theta, and which can be further written as I0 by 8 by, here you would be having by 2. So here I would be having it I0 by 16 1 minus cos 4 theta would be I0 by 16 1 minus cos 4 omega t. So let us check out which option is correct. So we would be having it I0 by 16 1 minus cos 4 omega t. So our correct option for this problem is option A. A continuous Heine laser beam is chopped using a spinning aperture into 1 microsecond square pulse. The order of magnitude estimate of spectral width delta lambda of the emerging pulse light is. So we are having a laser beam, now it is chopped and resulting beam is square pulse. So we have to determine the spectral width. Solution. Delta change in frequency is equivalent to 1 by time period. Now delta mu we can change it, write it like mu will be c by lambda. So delta mu would be equals to c by lambda square delta lambda. Here we are just considering the modulus values. Negative, we have neglected negative because it does not make any sense in the calculation. So we just write it down here, c lambda square mod delta lambda is equals to 1 by time period tau. So spectral width with delta lambda of the emerging wave is delta lambda is equals to lambda square c tau. Now we are gonna substituting the values of what is lambda here. Lambda is 632.8 nm. C is 3 into 10 to the power 8 meter per second and tau is 1 into 10 to the power minus 6 second. Now substituting this value here, so we would get delta lambda modulus is lambda square c tau equals to 632.8 into 10 to the power minus 9 square divided by 3 into 10 to the power 8 to 1 into 10 to the power minus 6 equals to 1.33 into minus 15 meter. So let us check which option is correct. That means option C is correct for this problem. This is a 3-mark NET problem, numerical aptitude type test type problem, where we have to determine the values. So let us read the statement of this problem. A thin film of water having refractive index n is equals to 1.333 float on the surface of a beaker of silicon having refractive index ns is equals to 1.40. The arrangement is illuminated by 600 nanometer light incident normally from the top and large region of the film appear bright red. What is the minimum possible thickness of the film? Solution. Now here we have to understand two things. First, this is water and another oil having refractive index 1.40, water refractive index 1.33. So now there are two interfaces. First interface is air water. Now in this interface light is going from rare to denser medium. This would introduce a phase by 2 of lambda 2. Now second interface is water and oil. because this is having refractive index 1 and this is 1.33, water is having 1.33 and oil is having 1.4. So light is again traveling from rare to denser medium, and this will again introduce a phase difference of lambda by 2. That means in both the cases additional phase difference of lambda by 2 is introduced. So let us write down what would be the condition of constructive interference in this case. Now, because there is a phase difference lambda by 2, path difference due to reflection at both the air, water and water silicon oil interface, the condition for constructive interface is that twice the thickness of oil film is equal to an integer multiple of wavelength of light in the film. That is, we know it, 2 mu t cos r in general in this case would be equals to m lambda. Since r is incident normal, that means light is incident at normal, that means r is 0, which implies 2 mu t equals to, you can take it here n as well, so I would be writing n lambda, and implies t would be n lambda by 2 mu. So for minimum thickness n is equals to 1, that means t would be lambda by 2 mu, which is 600 nanometer divided by 2 into 1.33, that is 225 nanometer. So if in this case for the problem we are dealing with the condition of maxima is written by 2 mu t cos r equals to n lambda, but when, so let us first write it down. The answer for this problem would be 225 nanometer. Now if the interface would be like, first denser to rare and rare to denser and then denser to rare. For example, if we consider interface like air, water, air, there would not be any oil like this one. In such cases, so in first interface, that is air, water, part difference will be lambda by 2. Second interface, water, air, there would not be any path difference. So that would be 0. So in here the condition was modified to 2 mu t cos r equals to n plus half lambda. So the interface is like here you can check it out, rare to denser and then denser to rare. So you just have to remember this condition where it is moving from rare to denser or where it is moving from denser to rare. The condition would be modified accordingly. So answer for this problem will be 2225 nanometer. A laser has output power of 150 milliwatt with beam diameter of 2 millimeter at a wavelength of 630 nanometer. What is the value of electric field in units of volt per meter? ठीक है, use Coulomb constant 1 by 4 pi epsilon naught 9 into 10 की power 9 Newton meter square per Coulomb square. So solution. The intensity of an EM wave is given by I is equals to 1 by 2 epsilon naught or C into A square, where C is the speed of light, epsilon is permittivity, infrared space, and E is electric field. Now further, intensity is defined as the amount of power per unit area transmitted by the light. That means, or that is, I is equals to P by pi R square, or power would be pi R0 square into I, or P would be pi R0 square 1 by 2 epsilon naught C A square, implies E would be 8P by 4 pi epsilon naught C R0 square. So substituting the value of all parameters, we get the electric field as E is equals to 8P divided by 4 pi epsilon naught C R0 square equals to 8 into 150 into 10 की power minus 3 into 9 into 10 की power 9 divided by 3 into 10 की power 8 into 1 into 10 की power minus 6 equals to 8 into 15 into 9 into 3 into 10 की power 5, which is turning out to by 6 into 10 की power 3, that is 6000 volt per meter. So our answer for this problem would be 6000 volt per meter.